As you just saw, this is my shift register for week 7, part 2 of EE120 with Professor Vincent. For the shift register to work, you need to press down on 2 of the 3 buttons, the data button and the clock button. If you press and hold the data button, and then press the clock button once, and then immediately after that press the latch button, the first LED over here turns on. And then if you press the clock button again, and then the latch button, it bumps it down. And if you do this enough times, it shifts it down. And in binary number, originally, for only having one LED on, it started out as 10000, which is 0 times 1 plus 0 times 2 plus 0 times 4 plus 0 times 8. This is first 0, second 0, third 0, fourth 0, plus 0 times 16. It's the fifth 0, 0 times 32, 6 0, this is plus over here, and then plus 0 times 64. And for the last one, it's 1 times 128, I believe. And so once you add up all of this, you get 128. It started at 128. But for the next one, it shifted the 1 down. So it shifted to 0, 1, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. Sorry. So now that turns into, you start here, you have 0 times 1, and 0 times 2, 0 times 3, 0 times 8, 0 times 16, 0 times 32, but now you have 1 times 64. And now you have plus 0 times 128. And the shift register used is the 7495 shift register. We have a 6 volt power right here, not 9 volt, 6 volt. There's an on and off switch here. You have to flick it on in order to give it power. And then I have it connected, the power over here, and then the ground right there. And then it bridges the gap in the middle with these 2 small wires. And then if you go to the end, it bridges the big gap with this white wire and the orange wire. And has the same 2 bridges right here. The shift register is connected to power in 2 spots over here and ground in 1. In total, there's 3 buttons, 8 LEDs, and 8 220 ohm resistors right here to connect the LED to make it so it gets safely powered. And then I have 3 1000 ohm resistors for the buttons down here.